Hello everybody. Today we're going to talk about solving systems of linear equations by substitution. Now substitution is a little bit more difficult than graphing because there's a lot more algebraic steps that are involved. But if you know two-step equations, you should be able, and how to manipulate formulas, you should be able to do this fairly simply. The first thing that we're going to do is we're going to substitute the y value and solve for x. So in this case right here, we got lucky in this problem because there is an equation that has y by itself, so I don't have to manipulate either one of these to isolate a variable. So I'm going to go ahead and use this y value and plug it into this secondary equation. So in order to do that, you take negative 2x, then you have minus 3, and I'm going to substitute that y value, which is this whole part right here. So 6x minus 11 equals negative 7. I'll slow down just a little bit here so you guys can kind of get a grasp on this. So I took this part right here and plugged it in for y. Then from here, I'm going to go ahead and follow my order of operations. I have negative 2x. I'm going to distribute this negative 3 into both of these two terms, which gives me a negative 18x plus 33 equals negative 7. Combine your x's because they are like terms. Negative 2 and negative 18 is a negative 20. Doing this one step at a time so we can see how everything moves. I'm going to subtract 33 to both sides, which leaves me with negative 20x equals negative 40. Then from here, in order to isolate the x, I simply divide each side by negative 20, and these two cancel out, and x equals negative 40 divided by negative 20, positive x equals 2. Okay, now that we've solved for our x value, life gets a little bit easier when we make it to the second step because it's not as jumbled up, not as much work as what we did in the very first step. I'm going to go ahead and take this x and plug it into our initial equation, because if I'm going to be solving for y, I want to pick the secondary equation or the equation that has y by itself. So all I have to do is worry about this right-hand side of the equation. So I have y equals 6. And then I'm going to be plugging in this x value, which is 2, minus 11. And then from here, I just follow my order of operations, which gives me y equals 12 minus 11, and y equals 1. So in this case, y equals 1. So the solution to this system, your x is 2, and your y is 1. Now, because we're not graphing and we don't have a real visual representation of this system, it's a good idea to plug these two, or this input and output value, back into both of these two equations. And the math is fairly quick, and I'll show you that step right now. Take your very first equation, plug in the y value of 1. You have your 6, plug in your x value of 2, minus 11. And in this case, we have y equals 12 minus 11, and y equals 1. And as long as one side equals the other, this checks out. And then simply do the same thing for the secondary equation just to make sure it works for both, because according to our rules with systems, this ordered pair needs to be on both of these lines. So that means that I have negative 2 times my x value is 2, minus 3 times my x value of 1 equals negative 7. Negative 2 times 2 is negative 4. Negative 3 times 1 is negative 3 equals negative 7. And negative 4 minus 3 is negative 7. And that also equals negative 7. Therefore, this checks out for both, which means this ordered pair is on both of these lines. So this is the solution, and we verified that by checking our answer. That's it. Same steps, every single problem. The only thing that happens is the equations might change around a little bit, or they will, and you just simply follow the same steps. Good luck with that. If you have any further questions, make sure you email or ask some questions in class. Bye.